like an actor on the stage.
Sir, I have heard.
In addition, when I prepared, I always tried as much as possible to include the world that the students see around them. That's why I love to talk about rainbows, why the sky is blue, why the clouds are white, why rainbows are linearly polarized. So you relate it to their own lives. And therefore, when I do the demonstrations, where possible, I also include students. And then there is something else that is important in a lecture. You should never become boring. So therefore, I do demonstrations of which the students think that I risk my life. No way. So when I do the famous experiment with the pendulum, I make them think that that ball could hit my face. And so they are really, they're shaking in their seats. They are really afraid that something would happen to me. And I tell them, if that ball hits my chin, this may be my last lecture. And they believe that. I can make students in my lecture hall laugh. I can make them stop breathing. I can also make them wet their pants.
Okay, sir. That is nice. Sir, I've also heard that you have took a 6 months off from MIT. What was that for?
Since one lecture required about 80 hours of preparation, 80
hours.
80 hours, one lecture typically.
Man.
Since I gave 3 lectures per week, 3 times 80 is 240 hours. There are no 240 hours in a week, right? So I started working on my lectures always the term before the term that I lectured, and MIT always gave me the term off before the term that I lectured. That was a gesture given to all professors at MIT who lectured a main lecture course. That was also true in mathematics, that was true in biology, that was true in chemistry and in physics. So you would get the term before your lecture term completely off from teaching. And during that term, I prepared the lectures.
देखा एक्चुअली सर सही बोल रहे हैं. जब मेरे वीडियो 2 दिन में एक आते तो तुम लोग बोलते हो 2 दिन में एक वीडियो क्यों? प्रिपरेशन बहुत इंपॉर्टेंट होती है. एक अच्छा टीचर ना प्रिपेयर जरूर करता है ना सर. दूसरे सर तो एक दिन में 3 वीडियो डाल रहे हैं, आप 2 दिन में एक वीडियो, 3 दिन में एक वीडियो. करना पड़ता है बच्चों, तैयारी बहुत इंपॉर्टेंट होती है. देखो सर एकदम एग्जैक्ट वही चीज बता रहे हैं.
I want you to say one more thing. One more thing. I have given the lectures of 801 Newtonian mechanics more than once. And I have given also the lectures electricity and magnetism more than once. And also the lectures 803 more than once. Even when I gave it the second time, I would still dry run it 2 weeks before the lecture, 1 week before the lecture, and 6 a.m. of the lecture. The reason why you have to do that, you would overrun the time if you didn't do that. You have to really push it back again into the 50 minutes. In other words, if you play Hamlet as an actor and you play it 2 years later, you really have to do your homework again. It's the same thing.
Sir. Too much homework. Too much homework. True. When you have to repeat the same thing, then you have to beat yourself. You have to beat your own content. Well, you have to beat it. That is very tough. That happened with me last year when I launched the app. I taught in Laksh batch. That similar thing happened with me in my app.
Alakh,
yes,
one more issue, which is very important for me.
Yes. I
had a clock, a digital clock on my desk in the classroom. When the lecture starts, it reads 50 and it counts down to 0. The lecture is 50 minutes. In my lecture notes, I have every 5 minutes a number. That number is 50 on the first page. A little later, it is 45. Then it is 40. Then it is 35, and so on. So at any moment in time, I can compare the clock in my lecture notes with the clock on the table. So if I fall behind 1 minute, I know that. If I am ahead 1 minute, I know that. So when I finish my lecture, it is always within 30 seconds of the planned time of 50 minutes. Rarely ever within 1 minute. It's always very close. I never overrun by 1 minute. Students leave because students have to go to another lecture. So overrunning by 1 minute is deadly. That never happened to me.
Sir, is that real? That egg?
For my viewers, because they love that egg. My students at MIT also love that egg. And they often ask me, why are you wearing this egg on your shirt? And my answer always is, it's better to have an egg on your shirt than in your face. I have many brooches. This is the one that particularly, when I gave lectures for children, they loved this one.
Sir, I have seen you wearing this shirt since what, 2013 or 2014? What is the same kind of shirts you buy, or is the same shirt some lucky thing or what?
I have about 35 shirts.
Okay.
And many of them are quite colorful.
Okay, okay.
This shirt is famous for the reason that on May 16, 2011, May 16, 2011, I gave my farewell lecture for MIT, which is called For the Love of Physics. It's the same title as my book, For the Love of Physics.
Yes.
That lecture has now been viewed since that time by 13 million people. It is my most popular lecture.
Most popular.
And during that lecture, I was wearing this shirt.
Yes, yes.
So,
yes.
As a gesture to you, I'm wearing it again. Special day for me because of my interview with you. May 16 was my sister's birthday, by the way. May 16, 2011 was also a very special day. So yes, I'm wearing it in honor of you.
Sir, I have seen your video in which you visited the classroom after retiring and you got emotional. And I've also read about you that you are a scientist. What do you love more, teaching or being a scientist? A teacher or a scientist? What do you prefer more and why? Or is that a combination of both?
It's a very good question. I love both very much. And of course, during my 43 years at MIT, by far most of my time was spent on research. Yet when I was teaching, I couldn't do any research for reasons that I explained, right? It's completely obvious because of my preparation time. The wonderful thing about a university is that you can do both. Not can you do both, you have to do both. You would never get tenure at MIT if you were a good teacher. You have to, you must be world known because of your research. That's how you get tenure at MIT. Then if you happen to be a good teacher, so much the better. We have also very bad teachers at MIT. We really do. Because you get your tenure only based on your research, not on your teaching ability.
Okay. Okay. Got you, sir. Got you.
So MIT was an ideal place for me. I mean, I could do research at very high level. It was very well funded by NASA and by the National Science Foundation. And I had the option of lecturing for a large lecture hall, 500 students in a lecture hall.
So, sir, your major research were around astro, I think. Can you throw some light on your research part of astro? What actually fascinated you in astro? Is it about something about black hole or the radiations or the Doppler effect? Well, I really want to know in astro, what was your major concerns that you viewed over these years?
X-ray astronomy was discovered in 1962. I joined the group at MIT in 1966. There was another group of Riccardo Giacconi, who later got the Nobel Prize, at American Science and Engineering. That was an industry. MIT was very active also in X-ray astronomy. So almost anything you did in X-ray astronomy, I was one of the first to fly enormously large balloons, larger than the Empire State Building, 60 million cubic feet balloons to an altitude of about 130,000 feet, way above any airplanes. The reason why you have to get out of the Earth's atmosphere, that X-rays are absorbed by the Earth's atmosphere. So the early parts of X-ray astronomy in 1962, the discovery was done by rocket, 80 kilometers high. And so George Clark and I, George was first, I joined George's group. We pursued it with balloons. I had many balloons flights from Australia, from the United States. And then later, of course, we started launching satellites, because satellite is completely outside the Earth's atmosphere. So then you have no problem with absorption due to the air.
Sir, since you are an astronaut,
you obviously did whatever was possible to get the best resolution, energy resolution, to get the best spatial resolution, because only if you knew precisely where an X-ray source was, could you find the optical counterpart. In the first 4 years, even 5 years, there was no optical identification of an X-ray source, maybe with the exception of the Crab Nebula. But later, when the positions of the X-ray sources became extremely well known because of the sophistication of rockets and balloons, many optical identifications were found. You have to know the position of an X-ray source, if possible, better than a few arc minutes, in the hope to find an optical identification. 1 degree is not enough. There are too many stars in 1 degree.
Sir, this is a bit off-track question. So our students are very much interested in that you were into astro and everything. So like a nerd, I would like to ask, do you still believe that is there any kind of time travel possibilities? It's kind of a stupid question, you can say, but that's what revolves around all of us. And stupidity is physics, that I believe.
Okay, so your question is about time travel.
Okay. Yes.
Time travel is possible.
Wow.
We know that from Einstein's theory of special relativity, but only in a very special way. You and I are both on Earth. Okay?
Yes.
I leave the Earth in a rocket, and I go with extremely high speeds away from you. And then when I am 3 years older, listen carefully, when I'm 3 years older, I return to the Earth. You have already died 100 years ago.
Yes.
And I am only 6 years older. That is the way that time travel is not only possible, but it's even done, not with people, but it is done with radioactive isotopes that come into the Earth. So it's time travel is possible. In a way, I time travel to the future because you have already died 100 years ago.
Man,
so that means when I come back to Earth, it is no longer 2020, but it is 2120. So I have traveled in the future. I cannot travel back. So even my grandchildren would have died. You hear me?
Yes, sir.
All my
I hear
friends,
you.
my parents, my grandchildren, they all have died.
Sir, we wish you always
And that
keep
is
time traveling.
that is not fantasy.
It's not fantasy.
And that is not fantasy. That you are a physicist, you know that it's real physics, which has been tested. It is known in among students as the twin paradox. If they want to learn about it, they should Google the word twin paradox.
So we have the Indian version of that, Ram and Sham story given by our sir.
Scientific movies.
Sci-fi movies. Have you ever seen sci-fi movie? Are you into movies?
You don't watch science
No.
movies.